6-4 Applications of Linear Systems. Our objective: to choose the best method for solving a system of linear equations. So you're not going to learn anything new in this section. What you're going to do is you're going to take the tools that they gave you and you're going to choose which one you're going to use to find the ordered pair that matches both equations. Essential understanding. You can solve the system of linear equations using a graph, the substitution method, or the elimination method. The best method to use depends on the form of the given equation and how precise the solution should be. So here's what you need to pay close attention to. It's a summary. So the methods that we've learned is graphing, substitution, and elimination. When do we use them? So graphing, when you want a visual display of the equation, or when you want to estimate a solution. Substitution, when one equation is already solved for one of the variables, or when it's easy to solve for one of the variables. Elimination, when the coefficients of one variable are the same or opposites, or when it is not convenient to use graphing or substitution. System of equations are useful for modeling problems involving mixtures, rates, and break-even points. The break-even point for a business is the point at which income equals expenses. The graph shows a break-even point for one business. Notice that the values of Y on the red line represents the dollars spent. So here's our red line. That's our expenses. That's the money that was spent. That's the equation that is graphed. And that's the money spent. The values of Y on the blue line represent the dollars received in income. So Y is used to represent both expenses and income. An example is like the concessions, when you buy soda to sell in concessions. So the expenses is here's what it costs when we go and buy the soda. And then we start selling soda, here's how much money we're going to make. That line represents that. And so this point right here is the break-even point. So that means we could pay for the soda that we bought, that we're going to sell, but we didn't make any money yet. So anything after this point is when we start making money. Problem number 1, finding a break-even point. Business. A fashion designer makes and sells hats. The material for each hat costs $5.50. The hats sell for $12.50 each. The designer spends $1,400 on advertising. How many hats must the designer sell to break even? Write a system of equations. Let X be the number of hats sold, and let Y equal the number of dollars of expense or income. So our expense is Y equals, and it costs $5.50 per hat, so X is equal to the numbers of hats sold. And $1,400 is our advertising, so that's part of our expenses. Income, here's our money coming in, our income. So we make $12.50 per hat. So you can see hat is in each one, the number of hats that are going to be sold, and then Y for expense and income is the amount of dollars. So at this point we need to choose which method are we going to use to solve this, to find our ordered pair that works for both. We notice that this one says Y is equal to $12.50 x. So that's an important clue on which one you're going to choose. So we have our two equations, and so we're going to use substitution since both equations are solved for y. And here we have y is equal to $12.50 x. So that's substituted in for y. And now we need to solve for x. So we subtract $5.50 from both sides, divide by 7, x is 200. Since x is the number of hats, the designer must sell 200 hats to break even. So once they sell 200 hats, they did not make any money yet. They just broke even. They got to pay the bills. In real-world situations, you need to consider the constraints described in problem in order to write equations. Once you solve the equation, you need to consider the viability of the solution. For example, a solution that has a negative number of hours is not a viable solution. So it's not enough just to solve the equation now. We have to decide if it's a viable solution. So problem number 2, identify constraints and viable solutions. Zoo. The local zoo is filling 2 water tanks for the elephants exhibit. One water tank contains 50 gallons of water and is filled at a constant rate of 10 gallons per hour. The second water tank contains 29 gallons of water and is filled at a constant rate of 3 gallons per hour. When will the 2 tanks have the same amount of water? Explain. So we're going to write systems of equations. Let x be the number of hours the tanks are filling. So x is our hours. And y is the number of gallons in the tank. So we have 2 tanks, we're going to write 2 equations. So this one's filling at 10 gallons per hour. This one's filling at 3 gallons per hour. And then y is how much water is in the tank, whether you're talking about tank 1 or tank 2. Again, we can see both equations are solved for y. So we're going to pull the y out of this equation and put in the other one. So really we're just taking these 2 equations and making them equal. And then we solve for x. So we subtract 3x from both sides, subtract 50 from both sides, and end up with a negative 21. Divide by 7, and we have negative 3. And x, we need to remember, is the number of hours the tanks are filling. So for these 2 equations, x is equal to negative 3. So then we substitute in our negative 3 for x in either equation, and we need to solve for y. So 10 times negative 3 is negative 30, plus 50 equals 20. So we have to look at what this means. When x is negative 3, y is 20. The solution to the system is negative 320. The solution, negative 320, is not a viable solution because it's not possible to have a time be negative 3 hours. So the tanks never have the same amount of water. When a plane travels from west to east across the United States, the steady west to east wind acts as tailwinds. This increases the plane's speed relative to the ground. So here from west to east, here's your airspeed. You have to add in the wind speed, and that's how you get the ground speed. When the plane travels from east to west, the wind acts as headwinds. This decreases the plane's speed relative to the ground. So we take our airspeed and we minus our wind speed and to get the ground speed. So you can see in order to find the ground speed, we need to subtract out the wind speed. Problem 3, solving a wind or current problem. A traveler flies from Charlotte, North Carolina to Los Angeles, California. At the same time, another traveler flies from Los Angeles to Charlotte. The airspeed of each plane is the same. The ground speeds are shown below. What is the airspeed? What is the wind speed? So we look here, the ground speed is 550 miles per hour, and we have our wind speed on both of them. And our ground speed over here is 495 miles per hour. The planes are going at the same speed, but it's the ground speed that's different. This one's going against the wind, so it's going at 495. This one's going with the wind, so it's going at 550 miles per hour. It's the ground speed with the tailwind and with the headwind to write the system. Let A equal the airspeed of the planes and W the wind speed. So the plane that's going with the wind, we're going to add in the wind to get the 550. The plane going against the wind, we have to subtract out the wind to get the 495. So we have our two equations. So we choose our method to solve the system, and we're going to use elimination because we can see here we have a positive and a negative W. So elimination will work great here. When we add our two equations together, we get 2A, our W cancels out, and we get 1,045. Then we divide both sides by 2, and so A is equal to 522 and 5/10. So we substitute in the 522 and 5/10 in for A, and we subtract it from both sides, and so our wind speed is 27.5. So we have our airspeed at 522.5 miles per hour, and our wind speed is 27.5 miles per hour.